The majority of the parts for the helicopter have been completed, and you've gotten to witness all of that. This is the last video in the build process of the series, and it's just sort of a catch-up on some of the little parts that I made off camera, but they use the same techniques as all the things that you've seen. For example, this crank disc here, and there's another one just like it down here. It's just a simple turning with a hub, set screw, and a hole to hold the drive shaft. Let's hide that. Also, these two drive shafts, again, they're both the same. They're just piece of brass with holes in either end. The connecting rods, these little forks, I'll take you through some detail on how I did those, but they're cylindrical, but they have a hole through them for a pin, to hold onto the crank, and they also have a slot, because it moves back and forth. This fork, which is longer than this one, let's see if we can take a better look at it. This one runs all the way into the displacement piston. Let's find some more stuff here. So there's this part that we already made, which has the two O-rings, and that's what sits inside the piston. But then this shaft with the fork on the end of it runs all the way through. And it's important to note that this shaft is actually a tube. There is a small hole running all the way through. And the purpose of that, if we didn't have that, the heat buildup inside the piston would have no place to escape. Obviously we're heating the cylinder to create the motion, but the byproduct of that is that we're also heating the piston, which is completely enclosed and sealed off with these O-rings. So this hole through here is very important. It's just to let the pressure buildup release. We're also going to take a look at these guys here, which I think I call cup holders. But if you recall, when we talked about the thrust bearings, and we looked at them, they were pretty ugly. So all I've done is I've added to the plan this. It's a little cup. I mean, it's just a hollow cup, and inside it is the thrust bearing. So we'll take a look at those. And then, there are 5 miter gears in the helicopter. 2 more back here in the tail. We'll talk a bit about those. So let's head down to the workshop and take a look at these last few parts. We're almost done. I've been called lots of things. Perfectionist, obsessive, and here's probably an example of how I got that reputation. These are the screws that are going to be used to hold the helicopter together, and they just have a mill finish to them. They're dull, and when I screw them into all the parts that I've sanded and polished and so forth, they're just going to stand out like a sore thumb. So what I've done is I've tapped a little holder here for my lathe, and it'll hold the screws there, and then I will painstakingly sand and polish each one of them only about 25 of them or so. So this will take a ridiculous amount of time, but if I didn't do this, I wouldn't have the reputation of being obsessive perfectionist and all that other stuff. So this is what I'll be doing for the next, I don't know, hour at least. I just thought you'd get a kick out of that. I just wanted to bring you up to date on some of the smaller parts that I've made here. I didn't film the making of each of these parts because they use the same technique as you've seen before as I was making other parts, but just let me take you through them. For example, this is one of the crank discs. And it's nothing really complicated. It's just a piece of brass that was turned, and then I turned a shoulder on it. I added a set screw, one of the little 632 ones, and that will go through an axle and sit here, and that's what's going to run the drive rod that takes the work piston up and down through the cylinder block. And then I made another one just like it. It just has a shorter hub on it. But that one sits down here at the bottom. And that runs the drive rod that takes the main glass cylinder and drives it back and forth. In fact, the action of that cylinder turning this disc is what turns the flywheel and ultimately drives the rest of the mechanism. I made the rotor head for the tail, again, the same technique as the rotor head for the main propellers. That will sit back here out on the end of the tail rotor. What else? I showed you the thrust bearings, and they work very nicely, but they are ugly to say the least. So what I did was I made these I don't know, I'm calling them cup holders for lack of a better term, but what's going to happen is the thrust bearings sit inside them. It doesn't affect the way they work, but it hides them. So here, where we need a thrust bearing, for example, for the pulley mechanism, you won't see the thrust bearing. But that's just a thing for looks. And making these was just a matter of machining, turning some brass and boring a little recess in there. Again, nothing you haven't seen before. I told you that I was, actually I showed you that I was sanding the screws because they have this mill finish, which is nothing to look at. So I don't know if you're going to be able to see this on the video, but there is a considerable difference as to how they look after you sand them. It only takes a few minutes to sand each one, but 25 of them ended up taking a couple of hours. But I think it was well worth it. You can see them in here, how they they match better with the finished brass. Something else we need to take a look at is the helicopter needs 5 miter gears. And you're free to make these if you're going to follow along and build one of these, but As far as I know, everyone else who's built a helicopter of this type has just gone out and bought the miter gears, which is what I've done. There are lots and lots of companies that make these, and if you just do an internet search on miter gear, you'll find many, many suppliers. And they come in all different, sizes and materials. And obviously I bought brass ones, but you can buy them in aluminum, in steel, in nylon, acetal, and it's not going to matter. Any of them will work. The other thing that doesn't matter is the number of teeth or anything. The only thing that you do have to keep in mind is you have to sort of pick a size that's going to fit, in the work envelope that you've got, both in here. 3 of them end up in here, the center part, and 2 more go back in the tail rotor. But you can see, that these are, they're pretty small. The ones that I bought did not have a set screw on them because they were manufactured with a tight tolerance in the hole, and they are meant to be press fit onto in my case, a 1/8 inch axle. For this application, that wouldn't have worked well because I need the ability to, move these as I'm setting up all the tolerances and so forth. So what I did quite simply is I took my reamer that's, just 1/1000th of an inch larger than this hole, and I reamed them. So now, the axle will fit in there. And the other thing I did, I really doubt you can see this because it's so tiny, I put little set screws in here. Now these set screws are incredibly tiny. Their size is a 2/56 thread. But anyway, I went through and I took the 5 miter gears and I made those 2 adjustments. And again, you've seen me do those. You've certainly seen me ream things, and you've seen me mount parts in the vise and drill and tap them for set screws. So you really didn't miss anything there. I've also made these 2 forks, if you will, although they're not forks yet. That's the next step I'm going to work on. I showed you this in the CAD model, but this goes into the cylinder block, with the graphite sleeve in here, and this is what is going to be driven by the glass piston. But in order for this to connect to the drive rod, I've got to drill a hole through it, like this, and then rotate it 90 degrees and cut a slot in it. Because what happens is the drive rod, which is just made out of a piece like this, will sit in here and be pinned in with this, the hole will accept a pin going through it. I'm getting ready to make the 2 forks that hold the drive rods that push the pistons back and forth. And in order to do this, I've mounted my rotary table on the mill, and I've indicated it to make sure that it's square, this way and that way. And the way I did it, it's nothing complicated, it's just tedious, but I have a ground rod that's 3/8 of an inch in diameter, and I put that in the self-centering forge-draw chuck. And then I just run my indicator along the top of the rod, because that's going to tell me, if it's square this way. And then you just, tap it until you're getting the same rating as you travel across the rod. And then I move it to the back of the rod, so I'm measuring this way. And same process. It's just that you're tapping the table in the opposite direction. I don't do this any better than anybody else, and there are lots of videos on the internet that probably have better technique than I do. So anyway, rely on them rather than me for how to get this exactly squared up. But once it is square, I just use my my edge finder to find the center of this and the edge. So now I'm set up. The first operation is to drill a hole through here so we can put a pin in it, to hold the drive rod. So I'm just using my my sensitive drilling attachment, which just lets me, in essence, use the mill like a drill press. Okay. Now what I want to do is rotate the rotary table 90 degrees. So. And now I'm going to swap over to an end mill, because the next operation is to mill a slot through here. Alright, so now what I've done is I've switched over to an end mill. This one happens to be 5/64 in diameter. I'm just going to find Z0. There. And now all I'm going to do is use MDI commands, manual data input, and mill out a slot here. I'm just on each pass I'm lowering the bit, this time 7,000. So I started at 5, and I'm just trying to see how much I can do. It looks like I can get away with 7,000. Going through. Yeah, okay. So, so that's it. It's just a fork. You know, a hole for the pin to go through, and then a slot for the drive rod. Yeah, so that'll go through. Can't see what I'm doing from here. And then the pin will hold it in place. I think you've seen the rest of these parts, how I made them anyway. So I think that brings you up to date on, you know, what I did while you were sleeping. But again, you really haven't missed anything because you've seen all of these techniques up to this point. So I'm moving right along. I think I'll probably start cutting the axles to length, you know, which is no big deal. I mean, cutting is no big deal. Figuring out the exact sizes, it's like a little fiddling. But I think that brings you up to date on anything that I might have done off camera. So let's move on to what's next. Well, this is always my favorite part of the project. It's when you make the very last piece, and in this case, it's the plaque that's going to have my signature and the date that I made the helicopter. And I'm going to engrave that now. What I'm using for stock is a thin piece of aluminum that has a black anodized coating on it. You know, it comes in sheets. I've got it connected to a waste piece just with a piece of double-faced tape. I think that ought to be enough because all the forces are straight down. The technique I'm using is called drag engraving. Oftentimes people use an actual cutting tool, you know, that's milled to a ridiculously fine point, you know, like 5/1000ths width or something. And they put the spindle at an extremely high speed, and then they just, you know, actually cut the metal. You know, on a small mill like this, you know, maximum speed is 2,800 RPM, which is nowhere near the, you know, 10,000 plus that you need to do proper engraving. So, as an alternative, what a drag engraver is, there's a diamond in here, you know, a very fine point, and then this is spring-loaded. It's a very stiff spring, actually. So what's going to happen, well, first of all, the spindle does not get turned on, because we're not, you know, we're only dragging. What we're going to do is drag the diamond and scratch away the anodized coating and reveal the, you know, the silver aluminum beneath that.
What the G-code actually does is it, I've already figured out where Z0 is, where the diamond touches the part, but the G-code is going to push the diamond down an eighth inch further than that. Which of course is taken up by the spring, but what it's doing is, giving you a lot of downward force. And then it will just drag. So, enough yapping. Let's start this up and see what happens. I'm using a very slow feed rate coming down. I could probably speed that up a bit, but it's only coming down at a feed rate of 1. But once it gets to where it's going to move, I'm using a feed rate of 30 to actually do the dragging. This process takes a while, as you can see. Some letters it does very fast, and that's when the geometry is such, like when it did the H here. You've got 3 straight lines, so that's very simple, but it's doing an A now, because we're spelling out handcrafted. The A is broken into a bunch of very, very tiny line segments. It's just the way the software figures this out. So, it's treating each one as a separate move. So this will take a while, but hopefully it'll come out nice. And that's it. I'm looking at this and I'm wondering if these letters are possibly too big. It's very hard to tell when you're doing the CAD drawing, what it's going to actually look like when it's on the part. But I'll take it off here. I'll move it over to the, where it's going to be put on the stand, and I'll think about the sizing and so forth. And I might make it a bit smaller, do it again. But, this is the technique I use, and I just wanted to make sure that, you had an opportunity to see how I did that. The last part I made was the base for the model. It's made out of corian, which is it's an acrylic composite that is filled with minerals to give it weight, strength, and its color. And it's commonly used as a countertop material. When you buy it, it looks like this, it's unfinished. But it takes sanding extremely well, and you get this beautiful gloss on it. or a matte finish if that's what you prefer. I sanded this progressively all the way up to 12,000 grit, and I just used water as my wetting agent. What I'll do next is I'll glue the signature plate on there. And then you can see there's some grooves in here. That's the home for the helicopter. And then this circle up front is where the alcohol lamp goes. After I've got this glued down and so forth, what I do is I take cooking oil, just like corn oil or something, and I rub this down, and it's amazing how much more shine that will give it. And I've done this on other projects, and that lasts for years and years. It's just sort of brings out the luster and stays on there forever. The last step that I do is I have contact paper, and again, this is what you would line your kitchen shelves and drawers with and so forth. But the kind I buy is a cork material, and it's got an adhesive backing that you peel off. And what I do is I'll just adhere that to the bottom, and then you end up with a no-slip base. It'll just stay wherever you put it. So that's the base. There was nothing complicated. I mean, I just cut this out on a radial arm saw actually, and the rounding, I just did this with a handheld router, with a roundover bit. Just ran it around, and that's that. This material is incredibly nice to work. The only ports I did on the mill were cutting out this circle and these two slots here. Anyway, that's the base. The only thing I have left to do now is to lacquer all the parts, and then do the final assembly. I do want to point one thing out. I had said way earlier in the series that when I sand aluminum, I use a different micro mesh paper, the AO paper, and I wet it with water and so forth, which is what the directions from micro mesh tell you to do when you're working with aluminum. But this time around, I was experimenting, and I used the same MX paper that I've been using on the brass, with mineral spirits as the cutting agent. And I'm much happier with the finish I'm getting by not following the directions. So before you run out and buy that AO paper, if you have the MX, if you're using that on brass, try that on the aluminum. I'm just really pleased with the shine I've gotten. So that about wraps it up. We'll get back to you when we start doing assembly.